Solve the inequality and graph the answer on a number line. X squared plus 3x minus 28 is greater than 0. We can first start by finding the factors of this quadratic, that being x plus 7 and x minus 4. Next, what I want to do is to find my critical values. To do so, set each of these products equal to 0. So x plus 7 equals 0, or x minus 4 equals 0. Next, solve for each of those. Subtracting 7 from both sides, I get x equals negative 7, or adding 4 to both sides gives me x equals 4. Well, I can graph that on a number line where here would be my negative 7 and here would be my 4, and I'm interested in which regions then would contain my answers, or where would my solution set lie. To do that, I can come up with test points. A few points that I might check may be negative 10 to check this region, 0 to check my middle region, and perhaps positive 10 to check this right-hand region. If I put these values into my original problem, I get 42 is greater than 0, and that is a true statement. If I put 0 in, I get negative 28 is greater than 0, which of course is a false statement. And if I put 10 in, I get 102 is greater than 0, which is a true statement. Since negative 10 gives me a true answer, I know that my solution sets lie within this region. Since 0 gives me a false answer, I know that this does not contain my solution set. And since 10 is a true answer, I know that it also contains within this region. Coming down below, I can then graph that on a number line with negative 7, and I'm going to use an open dot because it's non-inclusive of the point, and 4. Again, an open dot. Next, let's graph the regions that we found from above, that being greater than 4 and less than negative 7. Lastly, I can write that in interval notation as negative infinity to negative 7 union 4 to infinity.